Hi everyone, welcome to my research data analysis using SPSS series. In this video, I will be walking you through how to properly code your Likert scale data. We will also look at how to prepare your data for SPSS. We will also look at how to run reliability tests on SPSS. And lastly, we will look at common mistakes that reduce reliability results. So we have the questionnaire here. This is a questionnaire, the instrument used to collect the data. So we have this section that collects the demographic information of the respondent. We have other section. We have a section B. Here is the main questionnaire. This section here, look, we have 12 items or questions here in this section. And this section altogether, all the questions here, they are to measure this construct, and also we have other sections. Section C, we have like 10 questions there, and the 10 questions, and the questions are to measure operational performance of commercial banks. And this also, we have section D is customer service performance. So all these 10 questions here are to measure this, and so on. We've collected. Let's go to the data set itself. So there is a data set. There is a data set. So there is a Likert scale data. What do I mean by that? Because this questionnaire measures the level of agreement of the respondent on each question. So what we're going to do first here, before we even think about performing or running reliability test, the first thing we're going to do on this SZ is to convert all these values, all these text, all this level of agreement to number. And we have our code book. Let me call it here. We have the questions are being, the responses are being rated. So we have it here. So strongly agree is 5, and agree is 4, neutral is 3, disagree is 2, and strongly disagree is 1. So this is how those responses have to be converted to number or to be coded. So we'll go to the data set again. Now I want to convert all these text to number based on what we have here. Now, first thing I'm going to do here is to turn this data to SZ table. So I'm going to press Ctrl T. So yours, I have header. My table has header, so I click OK. So the data is already in SZ table. So the next thing I'm going to do here is to code all these text correctly. So already have the values here. Strongly agree is 5, disagree is 4, neutral is 3, disagree is 2, while strongly disagree is 1. So you have your code book. Now I come here. What I will do is I want to use find and replace in SZ. So I press Ctrl H. So it will bring this out. Ctrl H. Now in my Ctrl H, I'm going to, what do I want to find? So let me start with strongly agree. My strongly agree, I'm supposed to replace it with 5. So I put 5 here. So if I will try this first, because we need to do the setting very well. We need to do the setting very well. So come to option here. When I come to option here, now you see we have I want to do the find and replace within sheet, the sheet where I am in. So you can choose anyone, is it row wise or column wise. So anyone is fine. So let me just pick, let me maintain the row wise and look in the formula. Now this space is very important what you're going to select here, because if you select if you tick this one, match case. So if you have anything that has any letter related to this strongly agree, so you can replace it with that. So what I'm going to do, let me give an example. If I put, let's say for example now, if I take this one, and I use let's say agree. Let me say agree is 4. Agree is 4. If I click OK here, what will happen is that what is strongly agree? So this strongly agree will be turned to strongly 4. Let me try that. You see now, strongly agree has turned to what? Strongly 4. Why? Because I'm telling you that anywhere you see agree, turn it to 4. So the strongly agree now as what? The agree there has been turned to 4. So strongly agree now has then become strongly 4. That is not what you want to do. Let me press Ctrl Z. So Ctrl H again. Now what I'm going to do is I will tick this, match entire cell content, uncheck this. So if I use this, the strongly agree, this one will not be affected. The strongly agree will still remain. So let me use this. You see now. So this is very important to select it correctly so that it won't give you problems. So, and I can now do my strongly agree. Strongly agree is 5. So select all. Okay. So let me now go to disagree, or let me use strongly disagree. Strongly disagree. And the one once you've done this setting correctly, this option very well. Anyone you want to change first, you change it, so there won't be a problem. So this strongly disagree is 1. Select all. Disagree is 2. While the last one is neutral. Neutral is 3. Sorry, neutral is 3. So make sure this one you are doing your coding very well correctly. So that's all. So we are done. Our data set is okay now. Here in Excel, we are fine. Yeah, we are good here. Yeah. Now, so what I'm going to do next is to import this data to SPSS. Import the data to SPSS. So I have my SPSS opened already. So to import the data, I will come here, come to File, import data. My data format is Excel. If in CSV, you have other options there. So I click this. So it take me to, okay, I have data on my desktop. And where is it? I use SPSS. Okay. It's SPSS training. So I click on this, click OK. Open rather. Click open. So now, if you have more than one sheet in that Excel workbook, you see the options there. So what I need is this sheet 1. So in the sheet 1, you see the preview of your data here. This is what we have. So if I select sheet 2, I already have where the key. This is what I have in sheet 2. So what I need is sheet 1. So I click this. Alright, this is my preview. So I click OK. So I have my data here in SPSS. That is good. Now, what you want to do now is to run reliability test. That's the next thing. We've prepared our data correctly. We've done the coding correctly. We are now in SPSS. So what we are going to do now is to run the reliability test. Now, running the reliability test, to do it correctly, number 1, when you have a data set that measures more than one construct. What do I mean? You see, this database management, these items here, as I explained from the questionnaire. So all these ones, they measure one construct. Yeah, to this item 12. Item OP, operational performance. So it doesn't measure another construct. So it is wrong for someone to bring all the items together because we have subscale in the data set. So it is wrong to bring all the items together at once and you are trying to find the reliability test. No, you need to do the test sections by section. And when you are running the reliability test, you only bring this numeric part into it. You don't necessarily involve all this gender, whatever. So this is not your question. This one are demographic information of the respondent. So your main questions are from here. So what I'm going to do now is you want to do the you can come to the variable view. I'm going to use just one section, one part. We don't have time to do everything. I'm going to use this impact because this one is not having more items. So I'm going to use this impact items variables here. So what I will do, let me change this to ordinal. Change it to ordinal because the data set here is in ordinal. So you can read about ordinal, scale, and nominal. So I'm going to use that one for my analysis. Now, when I come here, I want to do the reliability test using Cronbach alpha. So I come here, come to scale, reliability analysis. Now the variables that I want to use, the section that I want to use, I have them here from item 1 to item 6. So what I will do, I will click on the first one. You can bring them in one after the other. This one too in, but that will be a waste of time though. So let me take them back. So I'm going to do that. Click on this number 1, press shift on your keyboard, go to the last item, which is this. So it will highlight everything for you. You can move them once into this place. Now the test, we have different tests here. These are different tests. The common one is this Cronbach alpha test. So I click on this. Now I can put the result here. I can put it this way. Impact, that is a scale label. I can label impact reliability test result. So this is just to help it to identify what the output is all about, so that you won't mix the interpretation of your result. You won't mix it up. You won't mix the result in the result window. You won't mix them up. So what I'm going to click OK now. OK. So this is the result, reliability impact reliability test result. Now if we move down, when you look at the reliability test, the Cronbach alpha, you see it. We have 6 items in that variable. Yeah, let's go back. We have 6 items. Yeah, in that variable, in that in that section we have 6 items, which you can see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So when we look at the result, it's giving us the number of items. This is our Cronbach alpha result, which is a 0.50. Now, looking at this data set like this, looking at this result rather, we see that this result is telling us that that section of our questionnaire is not reliable, because for a questionnaire to be reliable, the Cronbach alpha result must be from 0.70 to around 1.0. So it can more than 1. So it be from 0.70 to around 0.9. But what we have here is low. So this one is poor result. So the next thing we need to do, not just throw it away, that this result is not okay. So what do we need to do now? What we need to do now is to diagnose the items in that section the items that measure the construct, so to diagnose what is wrong with the item. So we don't just throw this thing away that this questionnaire is not reliable, so we need to diagnose it. So how do we do that? So I come to this again, go back to my analyze, come here, come to this variable. So I will now come to this part, statistics. Come to the statistic part here, and I have some items that I can select. I'm just going to select two. So this descriptive for scale if item deleted, and also for what correlation. So I'm going to others one you need all this one, you can select them, but I don't need them for them. These are the two main things that I need for to diagnose this. So I click continue and I click OK. Now we see the result now. So the result here still remain the same, and when you scroll down now, this is intercorrelation, the inter-items correlation matrix. So this what this one is telling us, is telling us the correlation between the items in that section, the item between the items. Now this one to this is 1, which is normal, it's perfect. So if you look at this one down, is what is 1 1 1. Now what you need to look for here in this matrix, in this table, is that there should not, number one, there should not be negative correlation. So any item that is having negative correlation, that is what that call for cosines about that item. Any item that is having negative correlation, so that calls for cosines about that item. And number two, the correlation must be greater, equal to, or greater than 0.3. Must be greater than or equal to 0.3. So if you look at the items, where are we now? Let's look at this thing very well. If you look at this one, positive, so this one that is negative, positive, positive, positive. Only this one that is negative, this row that is negative. When you come to this item 5, you see everything here is negative. Apart from this one, everything here is negative. So it means that there's a problem with this item 5 in this questionnaire. There's a problem in this item 5 with this item 5. Maybe, so we're going to see where the problem is coming from now. And if you look at when you correlate the item with others, it's all negative, apart from when it correlates with itself. So that is on that. So the direction, for your this place, the direction must be positive, and what must have a correlation coefficient of 0.3 at least, can be greater than that. So we come to the second table. The second table here, you look at the second table. What the second table is telling us is that, especially this part, Cronbach alpha, if item deleted, is telling us that if we delete this item 1, our result, when we have it, will become what? 0.277. So now, it's telling us that if we delete this item here, our result will be this. If we delete this item, our Cronbach alpha will be this. If we delete this item, our Cronbach alpha will be this. If we delete this item, our Cronbach alpha will be this. Now look at it. It's telling us that if we delete this item 5, this point at item 5, our Cronbach alpha will be what? 769, which will make it be very what? Reliable. Now, so it means that this is telling us that there's something wrong with item 5, as you can see here. There's something also wrong with item 5. Any value here in this column that is greater than what you have here, when the value here is greater than the value that you have here, it means that that value, that item calls for cosine. Any item whose Cronbach alpha is greater than the overall Cronbach alpha here in this place, because it's called what? For cosine, which is this one. Now let's try let's remove this. Let's remove item 5 and see what the result will give us. So I go back to my analyze, reliability test. Let me remove that item. This is item 5. Let me remove it. Let's run the test again. You see it. So it's giving us the correct thing. So it's giving us 0.769, 0.769. So we can't stop here. Oh, now our reliability test result is now what reliable, because we're able to diagnose what is causing the problem. So we can't stop here now. We need to go back to the items and look at what is that item saying and know where the root problem, where the problem is. Now, if we look at all the variable here and this one here, they are what? They are almost the same. Well, this one is greater than this, but the difference is not much. It's not much. You know what? Greater than this, the difference also what is not that much. So we also look at this. Look at this. Everything correlates very well. If you look at this, item 4 is the one that's less than 3. This one is also one that's less than the 3 when it correlates with this item 1. When correlate with this item 1. So what we are going to do, next here is so it seems what we are going to do next is to run let's go to the questionnaire again. So let us go to that questionnaire and look at what is that item 5 saying. Okay, this item 5. You see now, this item 5, the way we did the coding, we did it in the wrong way for this item 5, because item 5 is question asked in the reverse direction, and we coded it the way we did for 1, 2, 3, 4, and 6, but we also have done it in the reverse direction for this item 5. So we'll go back to the questionnaire and do the reverse coding. We do it in the reverse way. So I'm not going back to my Excel. I will just use my SPSS to do that. Now, how do I do the reverse coding? How do I do the reverse coding? How do I correct the error with this item here? How do I correct the error? So what I will do, I come to my transform. The formula, if you want to do the reverse, want to correct the reverse coding of this, want to correct that, what we are going to do is the highest number here in this questionnaire is 5. In the coding that we use, strongly agree, is 5. So what we are going to do is that we add 1 to that 5, making it 6. So add 1 to 5, make it 6, and whatever value you have here, subtract it from 6. Let me repeat myself. Now you want to do the reverse coding. So normally this is 2. So this is this disagree, and this disagree. So the disagree means agree. That's just the meaning in this reverse coding. So you are going to your strongly agree will be what? Will be 1. Agree will be 2. Neutral will still remain 3. Disagree should be 4. While strongly disagree should be 5. So what I'm going to do is that the highest score I can have in the column here is 5. So I will add 1 to the 5 to make it 6. I will now subtract the value that I have here, each of them, from 6 to give me the proper coding of this column. So what I will do is go to transform. I will come into compute variable. Let me call it items 5 record. Okay, so what I will do is I've said the correct number is 6. I put 6. That's the maximum thing I can obtain there. Minus, put minus, where is that item? Minus item 5. Okay, I bring in my item 5. I bring it in minus this. So I click OK. When I click OK, like this. So we have created another column for me. So you see, I created another column. You can see now 2 from 6, 4. 2 from 6, you see 4, 4, 4. 3 from 6, give me 3. And you see now, so and so. So this is the correct coding of 1 from 6, give us 5. So that is on that. So what I can do now, I can decide to delete this. Let me delete this one now, cause confusion. Let me delete cut. I delete this, so I can bring this one in here. So I can bring this one in. Let me adjust like this. Bring this also adjust that. We want to make it to be like others. Just come to data variable view, this place, this decimal, make it to be 0. So it looks like others correctly. So let me come back. You see now, it's in the right way. Now, what I'm going to do now, I can make this. Oh, sorry. So let me correct the names. Let me correct the name very well. So I can rewrite the name. Let me call it impact. Let me call it impact underscore item underscore 5. So doing the proper. Okay, so I have it there. Now what I'm going to do now is just to it doesn't. So let me bring into analyze. Let me now analyze reliability test item 5. Okay, so bring it in. Let me now run the test again. You see now. So this now our correct reliability test result 0.807. So this is how to run reliability test, correct your error when the question is supposed to be coded in the reverse way, and make correct adjustment. So this is how to run reliability test Cronbach alpha in SPSS. And so you see, if we've ignored the question is not correct, we've not done all this diagnostic analysis, we might have made wrong conclusion on that questionnaire. So this is the first video and on reliability test. I hope this is helpful and you understand what I've just explained. Thank you.